Okay, so what are we doing? We are going to be looking at this. Oh, I can do it the other way. Anyways, because I want to go forward, but this time I'm going to go backwards because I know this is 4, this is 1, 2, 3, 4. And then we have 5. Nope, we have 8. And 8 goes to here. So we have 5, 6, 7, 8, 9. So this is what it looks like on the abacus. 5, 6, 7, 8. And then we have this number, and it takes us to here. So we have 1, 2, 3, 1, 2, 3. And then we have our 10. 10 goes here. From here, this is 1. And then here goes here. So we have 1, 2, 3, 1, 2. What we're doing is we're learning how to read the abacus. And then after we learn how to read the abacus, we're going to go into understanding how to add and subtract. So this book is available if you're looking for a puzzle book. This is what we're doing is we're going to be doing some abacus in the morning. We're going to be learning math in the morning. So what I just did is I took the 28 and I put it in here. So 28 on the abacus looks like this: 20 and then 8. I have my 10s, I have my 1s. 10s, 1, 2, 1, 2, right? This is 2, and then this is 8. 5, 6, 7, 8. Welcome. Good morning, everybody. Good morning. How is everybody doing? Welcome. So what we're going to do is we're going to do 55. So the first thing we're going to do is understand how to read the abacus. After we learn how to read the abacus, we will understand how to add and subtract and multiply. And maybe we do some division. I'm not sure. But the first thing we need to do is understand how to read the abacus. So we have 97. 5, 6, 7, 8, 9. What am I doing? I'm coloring in the active beads. I'm going to color in the counted beads. So we have 50, 90, this is 90, and then this is 7. And so we're going to go over here, and my question is 9, 92. So I'm going to put in 90, 5, 6, 7, 8, 9, 9, and then 2. Notice I have 1, 2. 2 looks like that. That's what 2 looks like. 92. And then my final answer is 51. So I do 50, and then I do 1. 51 looks like this: 50 and then 1. Good morning, everybody. Good morning. So if you look, this is what 51 looks like. We have a 5 and we have a 1. So, oops, I did it wrong. It's supposed to be this way. So it's supposed to be 2. So then this is supposed to be 7, 67, 67, 6, 7. 6, 7 looks like this, right? 6, 7. That's what that looks like. Okay? So then we have, what number do we have? We have number 7. 7 looks like here. 5, 6, 7. That's what 7 looks like. And then this was 51. Oh well. That's okay. Let's try another one, because I did that one wrong. Hello, everybody. Hello. 6, 7. Right? 6, 7. So when we're doing it, thank you, Raku. So what we're doing is we're learning how to read the abacus. Thank you, everybody, for joining and wanting to learn how to read the abacus and learn math in the morning. We're doing morning math. So when we do it, we have 1, 2, 3, 4, and then 5. So when we're looking, it's as if we're having money, right? You know how these are pennies. We have 1, so 1 looks like that. This is 2, this is 2 like that. This is 3 on the abacus, and 4. Easy? Raku, are you there? I don't know if you're there. Hello, Jeremy. So then, what are we going to do after 4? Well, we have 5. 5 looks like this. 5 is the top bead. 5 will always be the top bead no matter what. So that's 5. I don't know if Raku is here. So we do 5, and then we do 6. 6 looks like that, right? 6 is 5 and a 6, and then 7. 5, 6, 7, right? We had the 6, and then we had the 7. What are we doing? We're learning how to read the abacus. This right here is 7. And then we have 8. 8 looks like that. 5, 6, 7, 8. 8 together. 5 plus 3 is 8. And then we have 9. 5 plus 4 is 9. How's that going? Does that make sense? Anybody have any questions? Let me know. But what we're going to do is we're going to continue on with my reversed maze. I like this maze. Okay, so what are we doing? That's my reverse maze, and we are going to go this way. Hello, 10. 10 looks like this. Hello, Raquel. 10 is 1 and a 0. That's it. That's how you read 10. If you look, it's just like how you write it. It's exactly how you write it. So when we have 1 and a 0, our columns are 10s and 20s. So we have 1 and 0. So we have 1, 2, that's 11. I'm sorry. 1 and 1, that's 11. 11 looks like that. 1 and 1. And then what do we do? 1, 2, 2, 1, 2, that's 12. And then 13, 14, and then 15. How's that looking? Does that make sense? We're all right? Thank you, everybody, for joining. My name is Lynette. I've been teaching Abacus for 20 years. Oh no, thank you, Raquel, for the question. I do appreciate it. I have workbooks and worksheets all about the Abacus. Why is Abacus used? It's usually it's for kids, but I've noticed that a lot of adults are really interested in keeping their brain active. So it's very much like, working with Sudoku and puzzles and puzzles, word searches, and word searches, puzzles. It's like chess, jigsaw puzzles, word searches, and then I'm going to bring in the Abacus. And then there's chess. Hello, my name is Lynette. If you're looking for some books, I have it available in my TikTok shop, and it's also available here. Hello, everybody. Oh, I love these. I haven't seen them in a while. Thank you, TikTok T. Can you teach me the order of operation? Hello, Scary Masker. This is very cool. Teaching Abacus for 20 years. Yeah, I know. The order of operation, order of operation is multiply first and then divide and then go from left to right and then adding and subtracting. What I'm doing here is I'm doing arithmetic. Arithmetic, why don't you start at the end? Why don't you start at the end? Oh, on the Abacus, the reason why is because I have this dot indicator. This is my indicator that tells me the ones. So if you notice, I actually have two. I can do here or I can do here. So when I'm looking, if I did this one over here,
Pokemon, I choose you.
I can choose this one. So then I can count 1, 2, 3, 4. But then notice I only have a place for tens, and I have no more room for hundreds. So then what's going to happen is I'm going to go over here. Because I'm going to go over here, now I have my ones. So I can do 1, 2, 3, 4. But notice I could do tens, hundreds, thousands, 10,000s. Does that make sense? ST? So your username has 14191. So it'd be 19141. So your username has 14,191 here. Because you're over here, we have now decimals. Notice the decimal sits between the tenths and the hundreds. So because the decimal sits here, now I can do, I don't know, like change or whatever. Maybe 25. So if I wrote it, sometimes it's easier to write it and see it. So when I write it, it looks like this. 1, 1, 4, 1. I'll put a comma there, right? 91.25. You're really... Thank you, Bray. Yeah, I really do believe it's the greatest thing next to sliced bread, and a lot of people are interested. But I do have workbooks and worksheets and online classes and so forth. But yeah, it's like doing math over and over again for the 20 years. That's just like teaching grades, right? Teaching grade school. Okay, hello. Hey, Fake, how's it going? You're up early. All right, so we're going to continue on doing So yeah, that was a little bit about understanding how to read the Abacus. So here's my little maze to encourage people to make learning math a little game. So I've had 2 here. I'm going to put in 2 on my Abacus. That's what 2 looks like. 36, if I look, 30, and then 6. And what do we have? We have 30, 1, 2, 3, and then 6. 5, 6. Hello. I think this is such a wonderful way to teach math. Thank you, Lydia. Can you do... let's see. Can you do multiples of 2? Yeah, but multiples of 2 is like skip counting, and then you have to know like some formulas, because Abacus is not really... You need to understand how to add. right? So 2 plus 2, and then that'd be 6, right? So what did I just do? What I'm doing is I'm doing 2, and then do I have enough to add another 2? Yes, I'm going to add another 2. Can you do 74 minus 36? Yeah, but you might get confused. Why? Because you're jumping ahead. Do you want me to jump ahead, or do you want to get confused, or do you want me to go through in order? Let me know, because I can do any one. If I jump ahead, don't get mad. Don't get mad. And don't tell me that it's complicated because you don't know the basics. You don't know how to put your jacket on. If you don't know how to put your jacket on, then you're going to be cold. If you don't know how to take your jacket off, you're going to be cold. You're going to be hot. All right. So how do we do this on the abacus? On the abacus, we do 70, we do 4, right? Now, let me know. Are we going to do 6 first, or do you want to do the 3 first? That's also a thing too, right? Does it matter on the abacus? It doesn't matter, as long as you keep track of your numbers. You let me know, TikTok T. 3 first or 6 first? 6. So the problem with the 6 is what? We don't have enough beats to add the 6. Thank you, Fake. We don't have enough beats. Fake, you're going to keep up, right? Fake knows. So we're going to take away the 6. To take away the 6, we know we're going to have to minus the 10 plus the 4. Why? Because we need to take away the 6. Notice that this is a fact family. Fact family is what? The 6 and the 4 are friends, right? What we're going to do is we're going to make our numbers work for us. We're having no freeloading numbers. So what we're going to do is we're going to minus the 10 and then plus the 4. Because we have to plus the 4, now we have to do a two-step equation. A two-step equation is what? A two-step equation is when you have to put a number inside a number. Very similar to algebra. This is very similar to algebra. So if I do plus the 4 is equal to plus the 5 minus 1. So I'm going to plus the 5, take away the 1. That's it. That's my 6, right? So now I'm going to do this 3. I have to take away the 3. To take away the 3, Fake, are you able to keep up? So I have to take away the 3. What am I going to do? To minus the 3, there's not enough beats to minus the 3. What do I do? Well, very similar to the 5, right? To add the 5, I can take away the 5 because I have enough room to take away the 5. So I'm going to minus the 5 plus the 2. That's what I'm going to do. So what's going to happen? Yeah, see? Minus the 5 plus the 2. So my final answer is 38. Nope, can't keep it. I know, it's a lot. I'm telling you. Because TikTok T decided to jump the whole class forward, right? We don't know what to do.
And flick. Oh, you flick too hard, damn it!
Don't flick too hard. What does that mean? It all goes in order. You start going ahead, you start getting confused because now we're all cold. TikTok T, we're all cold. We don't know how to take our jacket. We don't know how to put our jacket on. This encourages the right and the left side break. Yes, it does, Lydia. Yes, it does. This is the way I need to learn it. Yes. So just as I mentioned, you can go left and yes, because calculations happen on your left and art is on your right. So that's why what you want to do is you want to hold the abacus, and you want to hold the abacus because why? It's very easy to move. Because it's easy to move, you might, if you bump your abacus, you might move it. Thank you. Jedi Professor. Jedi Hala. Thank you. TikTok T, I told you. I'm telling you. Anyways, so we're going back to here. But I appreciate the question and I appreciate the amazement. But my goal is not to lose people because a lot of people get scared of math and people get anxious. And what I want to do is I want to make sure and show you how easy it is on the abacus. So the first thing we're going to do is we're going to go back, and the first thing we're going to do is we're going to understand how to read the abacus. So we're going to do a few steps back and we're going to learn how to read the abacus. Is that all right? You guys, that's what I'm saying. You can't just be jumping. You gotta put your jacket on. You gotta take your jacket off. Is there a 3-digit hoop? Yes, there is. Thank you so much for asking. I made a 3-digit one, and it's also available but I haven't have it in my shop yet. But it is available. It is published. Thank you so much for asking. It is published, and it's over here. So my name is Lynette, and thank you so much for joining me. We're going to be learning how to read the abacus. First, we're going to do the double digits, and then we'll go into triple digits, and then we'll go into adding and subtracting. So that was 36, and now we're going to do 84. 84, where did you get your abacus? I sell it on my TikTok shop. Did I not pin it? Did I pin it? Oh yeah, I pinned it. So I also sell this on the TikTok shop. I also sell the other one too. I sell this one because size matters. This is a 13-column abacus. This 13-column abacus works exactly the same as the colorful one. So, hi, thank you. Yeah, not a problem, not a problem. I have a bunch of products in my shop if you're looking for any of these. I'm still trying to bring in the books into my shop, but, you know, obviously it's delayed. And so if you're looking for, if you want it right away, I do have the abacus right away. But if you want to order it here, my name is Lynette. Hello, everybody. Thank you for joining. Thank you so much for the hearts. Wow, I'm already at 500. So hello, everybody. What we're doing is we're learning how to read the abacus because we need to understand our tool. This is a math tool, and I believe it's better than counting bears. Better than the counting bears. So the first thing we're going to do is understand how to do Enrico. Hey, Char. Welcome back. Thank you so much for the love. Hello, hello, hello. We're going to do 84. 84. So this is 5, 6, 7, 8. And then we do 4. 1, 2, 3, 4. I can show you on my abacus. I do 80, right? And then I can do 4. So we have 84 on the abacus. And that's what we're doing. I know it's slow, but it's better to go a little bit slow before we get all stuck. So we have 24, right? We have 24. 20, and then this is 4. 1, 2, 3, 4. And then here we have 74. 74 looks like what? I add 70, 5, 6, 7, and then 4. 1, 2, 3, 4. So I have 74. And what I'm doing is I'm coloring it all in. So it's kind of like a smarter way to color because you're also learning how to read the abacus. So I was trying to bring in like something a little bit relaxing as well as understand how to read the abacus. So the way the puzzle is, the way this maze is I give you the answer and I ask, and you're supposed to color in the answer over here. So if I want to do 8, I need to do 8. I have to follow the path. I'm going to do 8. 5, 6, 7, 8. And then here is 82. 82 on the abacus is 80 and then 2. Thank you so much for the love. Thank you so much for the likes. So we have 82. We have 5, 6, 7, 8. And then we have 2. 1, 2. And then here we have 45. 45 looks like this. 40, 1, 2, 3, 4, and then 5. And then I have 45. Make sense? Thank you, Ben. Thank you, Ben. And then we have 43. We have 40 and we have 3. So I'm going to color in 40. 1, 2, 3, 4, and then 3. 1, 2, 3. And then we have 73. So I take it to here and I go 73. 70, 5, 6, 7, and then 3. 1, 2, 3. We have 70. We have 3. 1, 5, 6, 7. And then 3. 1, 2, 3. Notice I have my 10s and my 1s. I have my 10s and my 1s. And then I have this one. I'm almost done. So we have 86. 80. 5, 6, 7, 8. And then 6. 5, 6. On the abacus, it looks like this. 86. And our final answer is 49. So I'm going to color in 4 beads and then 5, 6, 7, 8, 9. How are we doing? All right. So that's one way of doing of my maze book. Here is another way, and I'm hoping everybody can participate. We are doing this one. So if I have my abacus and here is my maze, now you tell me what number do you think this is? So if I have my 10s and my 1s, I have this. Thank you, Char. Thank you, Char. Thank you, TikTok T, right? We're going to go slow. Thank you, Fake. So after 20, we have this one. This one's easy. What number is this? Thank you, ST. Right? We have this number. We have our 10s and we have our 1s. Thank you, Char. Thank you, Fake. No, Yellow. Yellow, what 73 looks like? 73 looks like that. 5, 6, 7, 1, 2, 3. 21. Thank you, ST. Thank you, TikTok, T, and Char. Thank you, Char. Thank you, Fake. Right? So what we're doing is now I'm testing you. What number do you think this is? This is tens, and then this is my ones. 26. Thank you, Char. Thank you, Fake. Thank you, ST. Thank you, TikTok T. Thank you, Jedi. This is 25. 25 looks like 20 and then the 5. What we're doing is we're doing 26. There you go. Thank you so much. We have 26 and then we have this number. We have our tens and our ones. What number do we think that is? If I have my tens and my ones, I'm going to color it in so it looks easier. 61. Thank you, ST. Thank you, TikTok. Thank you, Jedi. Thank you. STTV. TTV is 12. 12 looks like this. 1 and 2. So I have my tens and my ones. 1 and 2. Does that make sense? But the way we had it, we had 60, 5, 6, and then 1. So you're a little bit reversed. So 61 takes me to here. Now what do we have? We have our tens, which is this, and our ones. So if I have my tens and my ones, what number? Thank you, Char. Thank you, ST. Yes, 36. Thank you, TikTok T. Thank you, Fake. Thank you, Lala. Welcome. Are the blue ones always 5? Yes, Punk Bunny. It is. 5 is always the top bead. And your name has 88. So we do 88. So we have 5, 6, 7, 8. 5, 6, 7, 8. Does that make sense? So when we're counting, let's do a review. 1, 2, 3, 4. 1, 2, 3, 4. Now we do what? 14, 24, 40, 34, 44. And then we do 5. But this is 55. Then we do 56, 66, 67, 67, 67, right? 67, and then 77. Then we do 88. We do 90, 89, or 99. Make sense? Cool. So that's 36, takes me to here. When we do this, what number do we have? So if I have my tens, and I have my ones. So I have my tens. Thank you, Char. Thank you, Fake. 99. How do I know? Because it's 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. That's what I was thinking. TikTok T. Yes, so 99 takes me to here. And then what number do I have? I have my tens and my ones. So when I look, you know what? Oh no, it didn't take. Yeah, I'll have to do it later. So then we have, thank you, Char, Fake, TTV, Jedi, Punk Bunny. Yes, Punk Bunny, yes, right? 91. 91 takes me to here, and I'm now over here. So what number do we have this? This is our tens, and then this is our ones. This is easy, because somebody said it. 6, 7. Really? 6, 7. It is 6, 7. Maybe I should just do a whole book of 6, 7s. So we have 6, 7 over here, 67, and then we have this number. We have our our tens and our ones. So I'm going to color it in. We have our 5, and then here is 5, 6, 7, 8. So we have 58. Thank you. Thank you, Punk Bunny, Char, TTV, Jedi, TikTok. Hey, Miss Amy, welcome. I'm getting it right. It's so good, right? Fantastic. So what number is this? If I have my tens and I have my ones, I'm going to color it in so it's easier to see. So we have our, yes, thank you, Char, 26, 26, right? Woo, woo. Awesome, everybody. Miss Amy, TikTok, TTV, Punk Bunny. 26 takes me to here, and then we're over here. Great. I have my tens, and I have my ones. Hello, everybody. My name is Lynette, and I've been teaching Abacus for 20 years. Somebody said, that's a long time. I'm like, yes, it is a long time. But you know what? Not everybody does it. 54. Thank you, 54. How do you add with it? We're going to do that. Hold on, Sam. Let me put a pin in that, and we're going to start adding and subtracting. But the first thing I want to do is I want you guys to understand how to read the abacus, because there's no point for me to show you how to add if you don't know how to read it. You know what I mean? So let's put a pin in that, and we're almost done. If you know how to read it, then that's great. You're ahead. You're up to speed. Okay, so our final answer is what? That's easy. Thank you. Yes, thank you, everybody. Char, TikTok T, Punk Bunny. It's Miss Amy, TikTok T, Jedi. Thank you. Thank you, TikTok. And Snicker Socks. Woo. 3, Amy. No, Miss Amy. We have to remember the top bead. So we have the top bead, 5, 6, 7, 8. But how do you know where to start? That's a good question. So do you know that there's a dot right here? This is my indicator. This is my ones indicator. If you notice, I actually have 2. And so because I have 2, I can actually choose any one I want. If I choose this one,
I choose you.
if I choose that one, then this will be my ones place, right? So now I would have to do this. And we could use the ones. It'd be like 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. That's 10, 1, 0. However, because I chose this one.
Okay, Charizard, I choose you.
Because I chose this one, now I have more room for my digits. Does that make sense? So when we're looking, we can do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. That's it? Oh, yep, there we go. So that's my 10, my ones, my tens, my hundreds, my thousands, my 10,000. Yeah. No, of course, because you know what? It's a new thing that it's hard to see. If you had your own abacus, you'll see that there's dots here. So that's the same thing with the 13 column one. The 13 column one also has the same dots, right? And if you notice, they're grouped by 3. They're sections. They're grouped just like we do decimals. So let me put this away. If I was to make a big giant number, let's see if I can find my big giant number. Okay, here's my big giant number. So here's my big giant number. If I use this one as my ones, right? I can 1, 0, 0, 3,000, 0, 0, 4 million, right? Then I have my decimals, 0, 0, 2. Does that make sense? So these dots help label my sections as well. So it's easy to see where I'm going. If I start here and I know that I'm going to start here, then I go 1, right? 4,003,001 decimal 2. 002. Can you remind me what I should buy for a young child with a new abacus? Oh, hey, Teach. Yeah. So in my shop, I do have this one. If you're looking for it. Oh. I have my abacus, and then I also have my books. So this book is really about just in the beginning teaching how to read the numbers. So here's a question, right? Your child knows how to read the numbers. If your child knows how to read the numbers and understand the sequence of numbers, then you might want to going into understanding how to do the maze instead. And this is a 2-digit maze. This is not available right now. I did sell out. However, it is available on my here. And hello, my name is Lynette. I know you know me, but just in case, right? So it is available here, but I am trying to bring in more of these books into my shop. The preschool one, when we focus on it, is about counting and also the relationships and understanding how to read the abacus. Once we go into that, after we figure that part out, then we go into adding and subtracting, and which is what we're going to do right now. Thank you so much for the likes. Thank you so much for the likes. So that's what we're going to do right now, is we're going to understand, because we know how to read the abacus, now we're going to go into understanding how to add and subtract. Thank you. That's really neat. Was there something you suggest to start with? You know, for the adults, I would suggest to start off with the maze book. I do have 2 different ones. I do have another one. I have a 2-digit one and I have a 3-digit. Right now it's not in my shop, but it is available here. I did publish it over here. And my name is Lynette, and I've been teaching abacus for 20 years. I do sell the abacus online. I do sell the abacus on my TikTok shop. There's a 3-digit maze as well, and the 3-digit maze works exactly like the 2-digit. So it's up to you if you want to focus on 2-digit or 3-digit, but I made it very specific. And there's about 24, no, there's about, I think, 14, it's about 100 pages, and there's about 14 mazes for each type. So there's the regular maze where you have to find the answer, and then I give you this mask maze. This mask maze is to help, not look at the answers, because the answers are right in front of you. If you wanted to get it printed out, because I noticed that the paper is a little thin, I do provide a downloadable mask maze that you can download it for yourself, and you can put it on cardstock. That's what I did here. I put it on cardstock. What is an abacus? Hold on just a minute. So then this is the regular way, and then I started off with the reverse maze. That's where I showed you, this is where I give you the path, and you have to color it in. So it's kind of like reverse coloring. Thank you so much. Yes, not a problem. So, and then I'm actually starting my introduction to Abacus for adults, which blows me away, because I didn't think it was going to be that interesting, but I'm going to start that. And so this is the beginning parts of going down the line of introducing Abacus to adults. So, oldie, what is an abacus? An abacus is really just a counting tool. That's all it is. And what we can do is we keep our minds active. How? Because it helps us critically think, as well as keep our mind active. We do adding, subtracting, multiplication, and division. But on the abacus itself only tracks our numbers. And so it kind of is comparable, if you're looking at for as an adult, it's kind of comparable to Sudoku, crossword puzzles, jigsaw puzzles, word searches, and it could be like chess. It could be like chess, but it's not. There's a little bit of strategy, and that's where we're going to start going into some formulas. But that's what abacus is. An abacus is a counting tool. It's a counting tool. It's a math tool, and I don't know why we don't show it to kids, but here I am showing it to you guys, so you guys can spread the good word of the abacus. All right, so what are we doing is we're going to understand how to use the abacus. Now, the first thing we're going to do is understand that the abacus has beads, and the beads have a point. And because there's a point, because even though your hands might be big and burly, you should be able to move the beads with your fingers. This is a standard size abacus. The standard size abacus means that it's the same height, and the beads are standard, and this is how everywhere it is. Now, if you notice that when I'm using the abacus, don't flick. You want to be intentional when you move the beads, okay?
And flick. Oh, you flick too hard, damn it!
What happens when you flick is because your answers become wrong. And that's when that's the problem, right? Because the beads are very easy to move. You don't need to oil it. You don't need to oil it. It just happens. And this is all made out of plastic. Both of them are made out of plastic, and the only difference between the two is that one is longer than the other. The colors mean nothing. The colors mean nothing at all. It's all about the positioning of the beads. So if you notice, I have 5 here. If I did 5, that's all 5. This is all 5. If you notice, it's every time the beads are touching this horizontal bar, it is being counted. Thank you, Jedi Hala. Not a problem. Not a problem. And so what we're going to do is we're going to understand how to move the beads now. Now we're getting ready to understand this is also a mind shift, right? It's a mind shift. Why? Because in Abacus, we focus on the add-in. We're focusing on the number that we're trying to add, or the second number, or the third number. We're trying to focus on the number that we're trying to, combine everything. So if you notice, in mainstream, they focus on the result. So you want to divorce the result and marry the process. So what we're doing is we want to add the 5. We add the 5. My question is, can I add the 1? Can we add the 1? Yes, we can add the 1. So I'm going to add the 1, and my final answer is 6. We can do it again with 2. The way this book was broken up was we focus on the add-in. Can I do it? So if I have 6, 5, 6, this is 6. Can I add the 2? Yes, I can add the 2. So I'm going to add the 2. So my final answer is 8. Does that make sense? So what we're doing is we're understanding how to move the beads. So if I have 2, this is easy. We're not going to memorize 2 plus 2 is 4. What we're going to do is we're going to look at 2. Can I add another 2? Yes, I can add another 2. So I'm right there. Does that make sense? So now I have 4. What we're doing is we're not focusing on how to make a 4. We're focusing how to add the 2. It is a different way of thinking, and I understand that. And it's something that some people can or cannot do, which is fine. But it's just a different way of thinking, if that makes sense. And now we have 3. Because we have 3, it's the same thing. If I have 5 on my abacus, I'm going to add the 3. Can I add the 3? Yes, I can add the 3. So my final answer is 8. In mainstream math, I know what we do is they use dots, right? And you can count it, right? These are 5 dots. That's fine. That's fine. You could do it, not a problem. Or I could do it on the abacus. If I show you 5 and I know what 3 is, it's easy to subitize. Subitize means what? Subitizing means that if I look at the number, I know what it is. I don't need to count it. I don't need to say 5, 6, 7, 8. I know that this is 8. I know 5 plus 3 is equal to 8. Whereas in mainstream, you have to count it because it's hard to see that this is 8. So I could see 1, 2, 3, 4, 5, 6, 7, 8. You could use sticks, you could use tallies. It's up to you. But you still need to count it per, by grouping. Oh, that's the other thing. So abacus is kind of like tally. And if I did tallies, 1, 2, 3, 4, 5, and then 1, 2, 3. Kind of looks similar, doesn't it? All right. What's next? Well, we're going to do 4. 4 is easy. Why? Because there's not very many questions with 4. You can either add the 5 and then plus the 4 or take away the 4. Oh, but then if you notice, we're going to take away the 4. When we take away the 4, we move it away from the horizontal bar. So we add the 4, we go to the horizontal bar. We subtract the 4, we go away from the horizontal bar, if that makes sense. And then it's the same thing. With the 5, with the 1. We already did the 1. We added the 1. So if I have 9, I want to take away the 1. I can take away the 1. If I add the 1, I go to the horizontal bar. If I take away the 1, I go away from the horizontal bar. Does that make sense? Let me know if you have any other questions on how to move the beads. So it's again with the 2, right? If I have 3, and then 2. When I'm looking, it doesn't matter which 2 beads I'm removing, but I need to just remove 2 beads. If I had 4, I'm going to remove these 2 beads. So now you're starting to see a number pattern. When I have 5 or 9 and I want to take away 3, I'm taking away these 3 beads. That's what I'm doing. See? Okay, I got to remove that. So we have 7, 8, right? We have 8. So I have 8 on my abacus. I want to take away 3. Do I have enough to take away the 3? Yes, I have enough to take away the 3. So my final answer is 6. I'm confused with the blue beads. The blue beads is always going to be 5, no matter what. But thanks for letting me know. So that's what it is. The 5 is always, the top bead will always be 5. The blue bead will always be 5, no matter what. So when we count, we could do 5. 5, 5, 5, 5, 5, 5, 5, 5. And then here, 6, 6, 6, 6, 6, 6, 6. If I do 7, I do 7. 5, 6, 7, 7, 7, 7. 5, 6, 7, 7, 7, 7, 7. 8, 8, 8, 8, 8, 8, 8, 8. And then 9, 9, 9, 9, 9, 9, 9. All of these are 9s. So when I'm looking, I could do 1, 1, 1, 1, 1, 1, 1. 2, 2, 2, 2, 2, 2, 2. Exactly the same. Why do I start from the third column to the right? Hello, Maryline. So the reason why is because I have dots. I have these indicators. These indicators is my ones indicators. How do I make a 10? 10. 1 and a 0. So here's another way to make a 10. If I choose this dot over here,
Pokemon, I choose you.
Punk Bunny asked how to make a 10. So if I do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. 1 and a 0. That's how you make a 10. Well, then we can count it, right? 11, 12, 13, 14. And then, but if I choose this one over here.
Okay, Charizard, I choose you.
If I choose this one over here, now I have more columns to have a digits. So I have 1, 2, 3, 4, because my ones are here. I have my ones, my tens, my hundreds, my thousands, my 10,000. And then if you notice, I can, after the ones will always be the decimals, no matter what. No matter what. Because there's nothing after ones except for decimals. So after 4, we have 5, 6, 7, 8, 9, and then 10. 1 and 0. Make sense? Thank you everybody for joining. My name is Lynette, and I teach Abacus. I teach math. I teach math with an abacus. If you're looking for the abacus, I do have it available in my shop. I also have a bunch of books as well. It's all in my shop. If you're looking for more books, I do have it here, and I just published a new book, which was the 3-digit maze. It's over here. My name is Lynette. Hello, everybody. Hello, hello, hello. Thank you, Alida. All right. So what are we doing? So when we're looking, we're making the 4. When we take away the 4, we add the 9, and I want to take away the 4. So when we add the 4, take away the 4. My final answer is 5. And then what's going to happen is, now we're going to add the 5. What are we doing? We're understanding how to move the beads, but notice that we're looking at the add-in, right? The add-in is the number that we're adding. So if I have 3, I'm going to add the 5. That's where I'm here. So my final answer is 8. 6 is very similar. If I have 1 and I add 6, I take away 6. I add the 6, I take away the 6. It's very similar, right? You can see that there's a number pattern. So if I add the 6, it's 5, 6. And if I take away the 6, I just take away these 2 beads. That's it. If I had 9 and I take away 6, notice I'm taking away 1 top bead and 1 bottom bead. That's all I'm doing. Make sense? All right. So now we do 8. Same thing. We add the 1, add the 8. Bring it together, we take it away. We add it, we take it away. So if you know how to add, you'll know how to take away. Anybody have any other questions? We're going to continue on. We have a few more things to cover. So it's the same thing with the 7. So I have 5 and then 4, and then we want to take away the 7. Take away the 7 is minus the 5 minus the 2. And together, we take away 7. Now, the reason why I go one at a time is, like, we are big people. We know this. But the reason why I have it written out is so that we can see what it looks like. So if I add 5, I'm going to add the 5. If I add 4, I want to add the 4. So what we're doing is we're practicing how to move the beads. And then we want to take away the 7, we take away the 7. It's the same thing here. I know what 1 plus 8 is. I know what it is. But I also want to see what it looks like on the abacus, because we don't visualize our numbers very much. So what I'm trying to do is I'm trying to show you how to visualize what it looks like to add 1 and 8. So I'm going to take away the 7, and I have my final answer is 2. Thank you, SJ. Okay, so we're done with that. Any other questions? Any questions? Bueller? 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 So the next thing we're going to do is we're going to understand, well, what happens when we don't have enough? That's where this book comes in, and this book is also available in my TikTok shop. Yeah, they should teach this in school instead of confusing my son learning. Yeah, how old is your son, if you don't mind me asking? This one is available for, what I'm doing right now is I'm showing you the fundamentals. As we go through the fundamentals, then it will become scalable. He's 8. You might want to start him on Abacus. It's up to you. It's up to you. In the beginning, it will be confusing because there's 2 different ways of thinking. But then as he starts to understand it, he'll be able to understand how to use the abacus. Just finished 2nd grade. Oh yeah, yeah. You know, if you wanted to, you could start him off with the 2-digit books, the 2 digits and the 3 digits. And then go into doing the +5, because this is the fundamentals. What we're doing is I'm showing you the fundamentals. We all have to start with understanding how to read the abacus. After we read the abacus, right? That's what we did. We moved the abacus. Moving the abacus is fairly simple. And then after we move it, now we're going into adding and subtracting. Now, I'm not sure if you remember, but in school we're teaching the kids how to make a 5. That's fine, how to make a 5. But the thing is what we do in abacus is we power up it. We power up the addition sentence. And so what does that mean? Well, here is the question. The questions are very simple for right now, but then I'll show you how we scale it. How it becomes very scalable if you know the fundamentals. If you know how to take your jacket off, it'll be easy. Does anybody know where that came from? Take your jacket off? Take your jacket off, right? Take your jacket off, put your jacket on. I don't know if anybody else has watched that movie, but it's the same thing. Like, I'm old, right? So what we know is wax on and wax off. Paint the fence up, paint the fence down. So what we're doing is we're learning the fundamentals. We're learning how to understand how to move the beads. Karate Kid, right? Thank you, Karate Kid. So here, I have 3 on my abacus. Because I have 3 on my abacus, what am I going to do? Well, I don't have any more beads to add 4. But you know what? Let me put 3 on my book. I have 3 pennies. If I have 3 pennies, right? 1, 2, 3. I have 3 pennies. I'm going to add 4. But guess what? I don't have any more loose change. I don't have any more loose pennies. So I don't have any more loose beads. What can I do? I have this nickel. I have this 5 cents. Because I have this 5 cents, I can give you my 5 cents, right? It's more than enough. But that's too much. I need change back, so I'm going to take away the 1. I can show you on my abacus. I can add the 5, and I need to take away the 1. So what did we just do? Is we just did some...
You need modification.
Modify. So what's going to happen is, this is where our other... This is where understanding our fact families. If you look, it's very similar to algebra. So this is another book that I also created. This is a laminated dry erase book. It is available here if you're looking for an all-in-one, all of the formulas. What we're going to do is we're going to understand formulas. What did I just do? I took this fact family, right? This addition sentence. When I took this addition sentence, I isolated the variable. What is the variable? The variable is the 4, right? Looks very similar to this, doesn't it? Looks very similar to algebra. What did we do? Let's going to isolate the 4. We're going to make it by itself. And then we have to 5, right? But that's too much. We're going to minus the 1. We can write it again with commutative property. What does that mean? We're going to have a 4 is equal to minus the 1 plus the 5. Make sense?
Welcome to the real world.
So if I show you, I have 4. I'm going to have 4 on my abacus. Right? I have 4 on my abacus. I want to add another 4. Well, let me get my pennies out. So I have my 4. Because I have 4, I'm going to add another 4. To add another 4, guess what? I don't have enough beads. So I can give you my 5 cents, and now I'm going to ask for change back. So I'm going to ask for change back, and now I'm left with 8. I can show you on my abacus. So I have the 5, and I take away the 8. So my final answer is 8.
This is the way.
This is the way.
This is the way.
Does that make sense? So we could do it again with 2. Now what we're doing is we are compounding our information. We're compounding our concept. We're compounding our knowledge, right? So if I have 2 on my abacus, and then I want to add the 4. I'm sorry, I forgot my pennies. I want to add the 4. But guess what? I only have 5 cents. Because I only have 5 cents, what am I going to do? I'm going to take away 1. So I'm going to take away the 1. So I'm going to show you on my abacus. I add the 5, and I take away the 1.
Welcome to the real world.
Oh, that's the wrong one. So that's what I'm doing. I'm adding 5. How does that work? Anybody have any questions? We can do it again with a 3. So now what we have is, if you notice, we have a fact family, a set of fact families. What we're going to do is we're going to do 3 plus 2 is equal to 5. Because 3 plus 2 is equal to 5, guess what? That's what this is. Right? We can do the same thing. We can do 3 plus 5 is equal, 3 plus 2 is equal to 5. We isolate the variable 3, and then we substitute 5 minus 2. And then what happens? We can substitute it. So here, I can show you on the abacus. If this is for your child, what I do is I talk about the cats in the tree. So the cats in the tree is 5. There's always going to be 5 cats in the tree. So if I have 3 on my abacus, 1, 2, 3, right? If I have 3 on my abacus, thank you so much for the likes. I am going to put 3 on my abacus, and guess what? I go to the 5 cats in the tree. Now when I go to the 5 cats in the tree, that's going to the 5 cats in the tree. And then what? I grab 3 cats, but 2 cats run away. So I'm left with 6. Do you know? Looped seals. It doesn't look like it. Your back looped seals with 34 followers. Okay. I'm not sure what you're talking about. Ha! How old are you, child? Haters, ignore them. Yeah. He's a kid. All the kids are very pessimistic. They've been hurt in their life. They don't know what it's like. All right. So, does anybody have any questions? We're going to continue on, but this is the basics, right? What we're understanding is the basics. I'm learning and he's interrupting me. Christopher. Yeah, because he's just a kid. All right. So what are we doing? So I can continue on to, what we do is we don't memorize our doubles, right? Doubles is this, 3 plus 3 is 6. We've memorized this when I was a kid. And that was a long time ago. So what we're doing is we're understanding this concept. The concept is what? 3 plus 2 is equal to 5. Some people are confused, right? And it's like, well, it's just like money. We give you $20. If I have a product that's $15, I give you my $20 bill, I'm going to expect change back. So we bring in this concept of, balancing the equation. And so what we're doing is we do 4. When we do 4, right, we have 4 on the abacus. I want to add the 3. Guess what? I have my 5 cents. Because I have 5 cents, that's too much. I'm going to take away 2. Now, if I look, I have 5 and I take away the 2. So my final answer is 7. 7. Make sense? So we could do it again. Let's try this one, right? 1. We add the 1. Can I add the 3? Yes, I can add the 3. I don't need to use the formulas. I just add the 3. 1, 2, 3. That's where you start getting critical thinking. Critical thinking is, do you need to use it? We don't just blindly answer questions, right? What we do is we look at our numbers and we ask, can I do it? Is there enough? When we have it, we could do it again with 2. But when we do it with 2, right, there's only 2 questions. Because why? Because it all depends on how many beads we have on our abacus. So if I have 3 and I have 2, right? If I have 3 on my abacus, I want to add 2. Again, I'm going to take this 5, I'm going to remove it. So I'm going to add my 5 and I take away the 3. So my final answer is 5, which is fine. But here, let's do 4. If I have 4 on my abacus, I want to add the 2, I'm going to add the 5, and I take away the 3. So my final answer is 6. I have 5, and then take away 3. Now, it's different if it's here. Why? Because I have enough beads. I have 2, and I add another 2. And that's it. Right? 1 doesn't have a lot of questions. And then we're done with this set. So we have 3 on our abacus. Can I add the 1? Yes, I can add the 1. So I just need to add the 1. Now let's look at here. So if I have 4, I don't have any more beads to add the 1. There's no more loose beads. So I need to add the 5 and take away the 4. And that's it. And then what I did with this book, depending on how old the child is, I added activities to strengthen and practice. And then if they already know, and the idea is to get them to understand this concept. And the questions are very specific because if you just answer the questions, it's very specific to adding the 5. And that's what this book is. What we're doing is we're practicing how to make a 5. How to utilize the 5. And I have a bunch of activities. There's like word problems and hidden words, right? You answer the question and they're all like how to make a 5. 3 plus 3, 4 plus 3. And then there's color by number and my mazes. I like mazes. So there's a tic-tac-toe. Answer the question and then place your marker. That's it. And I try to make it more fun than what we have. So like I did an example here. So I answer the question and I put my answer. And then I showed number bonds, but Abacus doesn't need number bonds. The reason why is because I just wanted to show the relationship between the 1 and the 4. And then we have more mazes, and this is available in my shop right now. And then the answers, in case you're wondering, the answers are in the back. I have a little sticker. Well, not sticker, but I have a little, maybe make this a little certificate saying that you understand how to make a 5. And thank you, Punk Bunny. And so the answers are in the back. I made sure that I try to make sure that I don't have a typo. So that's how I'll go through my questions. And the questions are all curated for the specific one. So then you might be wondering, well, what happens after 5? Well, after 5, you minus the 5. And that's another book. The reason why I broke it up to this is because I didn't want to overwhelm the children. The other reason why is because if I added everything together, I don't feel like that there's enough practice. So that's why every book is about 100 pages. And that includes the answer sheets. So now we're doing the -5. When we do -5, again, thank you so much. Again, what we're doing is we're understanding how to take away the 5. Which is, you know what? You're going to start seeing that there's a number pattern. Because there's a number pattern, you're going to see it. So let's start with the 4. Right? Guess what? Looks very familiar, doesn't it? Minus the 4 equals minus the 5 plus the 1. What? Yeah. Because if you look, let me see, if you look, we did it the other way. Plus 4 is equal to plus the 5 minus 1. This is minus the 5 plus the 1. Now you're going to start seeing a number pattern. What is the number pattern? Well, here's the question. If I have 8, I want to take away the 4. When I take away the 4, I'm going to take away the 5 plus the 1. See that there's a number pattern? When I want to add the 4, I'm doing this. When I want to take away the 4, I'm doing that. And that's when you start seeing number patterns in Abacus, right? I know they talk about number patterns in math, in mainstream math, but I don't see it. Whereas in Abacus, you can see that there's a pattern. That one is... Oh, I don't have that. This book, I don't have it in stock, but it is available in the other one. Yeah, it is available here, right? I'm waiting for my shipment, and then it'll be easier when it's on my shop. But just so you know, and again, I explained how to move the abacus, and then if you notice, we can keep going. We can add 16, right? We have 16 in our abacus. And I want to take away the 4. When we're looking at it, we want to look at this column. We don't need to look at the whole thing. We don't need to do 16. What we're going to do is we are going to look at this 6. We want to take away 6 from this column right here. We don't have enough beads to take away this 4. So that's where we understand minus the 5 plus the 1. Minus the 5 plus the 1. So when I remove my column isolator, we have 12. Does that make sense? So when we're looking, right, we look at every column. It's the same thing with mainstream math. You look at one number at a time. But in Abacus, it's more obvious. So we could do it again with the 15. 15, and I want to take away 4. Because I'm taking away the 4, what do? Minus the 5 plus the 1. Minus the 5 plus the 1. My final answer is 11. Thank you guys so much for the likes. Thank you so much for the likes. I appreciate that. Thank you again for the likes. Thank you for the follow, Claire. Anybody have any questions? I caught that one. Oh yeah. Wait, you got the concept or you got the answer, right? You got the answer? Makes sense, right? It's quite interesting. It's really quite interesting. We could do it again with a 3, right? So we have 7. We have 7 before you said the answer. That's fantastic, right? That's fantastic. And that's the thing. So that's what I did here is I wanted the kids to write it out. And I'm going to get the adults to do it too. Because I want you to write it out and kind of visualize and understand. You're going to minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. Minus the 5 plus the 1. And then as you say it more often, you're going to do it. And it'll become more intuitive. I'm absolutely terrible at math. Oh, you're going to like this one. Burning spice cookie. You're going to like the abacus. I do have a lot of people that don't like math. And when they use the abacus, it's really quite interesting on how it's become nice to them, if that makes sense. It's become, I'm not finding the words. It's become cool, fun. It's become fun. I don't know. I'm trying to figure out some words. I'm lost at words right now. So here we have 7. When we had the 7, right? Burning spice. Did you just come in? Let's do a little review. So let's do a little review for burning spice, yeah? So we do 1, 2, 3, 4. This is how we read the abacus. What we're doing is we're learning how to read the abacus, and then I'll go into how to subtract. And then I'll do some subtraction. That's kind of cool. Why subtract the top bead? Sorry, I'm just thinking. Because we're replacing and substituting minus 3. So if you look at 7, there's no more beads to take away 3, right? There's only 1, 2. But guess what? I have an overflow. I can utilize this 5. That's why you subtract the top bead. But if I take away the 5, that's too much. I need to balance it. I need to add the 2. That's why. Because it is the way. Oh yes, I just got that on as well. Oh yeah, okay. So the difference is we're further on into the lesson. So let me go back and let me show you how to read the abacus. So we have 1, 2, 3, 4, because we have 4 and then we have 5. The top bead is 5. When we add 5, right, these are all 5. So 5, 5, 5, 5, 5, 5, 5. And then we could do 6, right? 5 plus 1 is 6. We do 6, right? This is 6, 6, 6, 6, 6, 6. And then we have 7, 5, 6, 7, 7, 7, 7, 7, 7, 7. And then 8, 8. This is what 8 looks like. 5 plus 3 is 8. And then 8, 8, 8, 8, 8, 8. And then 9. We have 9. 5, 6, 7, 8, 9. 9. 9, 9, 9, 9, 9, 9. Does that make sense? So what we're doing is now we're going to understand what does each column mean. Now we know how to read the abacus. Every column is the same number. But now when we understand it, now we can put place values with it. So we have our ones, our tens, our hundreds, our thousands, and our 10,000s. Does that make sense? So the question might be, well, what's mid-10? Well, we have 9, 5, 6, 7, 8, 9. What happens? This becomes 10. Notice this is 1. How do you write 10? 10 is a 1 and a 0. It becomes very visual. Now we could do 11, and then 12, 13, 14. After 14, we could do 15, and then 16, 5, 6, 17, 5, 7, 18, 5, 8, 19, 5, 9, and then we do 20. It gets easier as she goes. It's actually quite fun. Yeah. Thank you so much, Punk Bunny. It's just a different way of looking, and it's just a different way of looking. And as you keep looking at the abacus, it's like typing on the keyboard. I was going to say typewriter. That's how old I am. So when we're looking at it, it's just like, playing a piano or, typing on the keyboard. You're going to get used to it. And as you get used to it, you'll start to be able to see how it looks. And then you'll be able to see everything. But the first thing we're going to do is understand how to read the abacus. When you understand how to read the abacus, then everything becomes known. So there's a couple of things, right? We have 2 dots. If you notice, there's 2 dots. I use this one or I use this one. So if I use this one,
Pokemon, I choose you.
excuse me, what does that mean? Then I move everything over and I have my ones over here. So I could do 1, 2, 3, 4, and then 5, 6, 5, 6, 7, 8, 9. And then this is 10. Notice now, if this is 10, I can count by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90. But now I have no more room for 100. What does that mean? That's why I choose this one over here. If you notice, there's a dot right here. That's why I choose that one.
Okay, Charizard, I choose you.
Then I have my ones, my tens, my hundreds, my thousands, my 10,000s. Thank you. SOH. Stay at home? No. SOH. So, thank you, so. Yes, I think it's awesome too. I think it's the greatest thing next to sliced bread. So now we can talk about 1, right? 10. This is 100, 100. This is 1,000, 1, 0, 0, 0. 1, 0, 0, 0. Then we could do 10,000. 10, 0, 0, 0. Cool? Okay, how's it going? Hey, Digi, welcome back. I just saw you. I'm doing well. Thank you so much. Hello, Mr. M. Negative numbers? No, we don't do negative numbers. We do subtraction. Just like in mainstream math, we do subtraction. It's kind of a negative number. Oh man, 11th grade is going to be hard. Interesting as seeing how it would work. No, because how do you take away 9 pencils from 2? You can't, physically you cannot take it away. Abacus just tracks your things. I've learned 2 things today. This and don't. Leave the food in the oven for an hour and a half. Right? We're talking about counting. When you count, we count objects. That's what this is. We're counting objects. If you want to do negative, you have to keep that in your head. We do the calculations in our brain. I'm showing you on a piece of paper, but we're actually doing calculations in our brain. I put the oven, it's supposed to be 20 minutes. Oh, I forgot until, that's really dry, Diggy. So that's what we're doing here is we're going to do taking away, right? We're doing subtraction. We have 7, and notice I don't have enough beads, so I take away the 5 and I add the 2. So what we're doing is we're understanding our concept. This is a concept, and then we just compound. Oh, okay. So, anybody have any questions? How are we doing? We can do this number. We can do 16. So we have 1 and 6, right? 16. Oh, it tastes like burnt carpet. Oh, that sucks. Okay, so we have 16. We want to take away the 3. When we take away the 3, what are we going to do? We're minus the 5 plus the 2. Because look, we have a way to take away the 5, but that's too much, and we have to add the 2. And my final answer is 13. Right? So what's next? Well, okay, we know how to add the 5. We know how to take away the 5. Are we okay? How are we doing? If not, I'm going to continue on with the concept. We're going to continue on with the more books. I've got books. So let me know. How are we doing? Are we going to continue on, or should we continue with how to make a 5 and how to subtract a 5? It might be easier to see what it looks like to take away the 10. Why? Because 10 is more common in mainstream math, which is interesting. I don't know why in mainstream math they teach how to make a 5, but in Abacus it makes sense because that's one of the core things. So here we do 8. Why are we going to do 8? Because we don't have enough beads to add the 8. So when I look, I have 8 on my abacus. No, I don't. I have 8. There we go. I have 8 on my abacus. 5, 6, 7, 8. What I'm going to do is I'm going to add 8. When I add 8, what do? I have 10 cents. So if I have 10 cents, that's too much. What am I going to do? I'm going to take away 2. It's interesting because why? Because in mainstream math, you count up. But in Abacus, you do a balance, which is very interesting. Because, why? I don't know why. I don't know why we count up. Because somebody was like, okay, and they got confused with taking away the 2, which is interesting. Why? Because if I have the 10, that's too much, because I have a reservoir. I have a reservoir of items. I have a reservoir of 10, but that's too much. I need to remove 2. So my final answer is 16. My final answer is 16. Does that make sense? How did they do it? They wanted to count up. So they were talking about 8, counting up. So it would be 9, and then 10, 11, 12, 13, 14, and then 15, 16. You could do it that way, but that seems a little bit long. I'm going to quickly redo my food. Okay, see you later, Diggy. Yeah, I don't know. They were kind of they were refusing, not refusing, but they were not understanding why to use the formulas. And I think I should have been here, right? Because we can do more. You can count up, but it gets more, it gets cumbersome because you have to track the amount of numbers you do. We can do it again with the 7. So here I have 7, right? If we know, is it a shortcut? If we know how to add the 10. So I have 7 on my abacus. I want to add the 10. Why? Because I have enough money. I have 10 cents. Because I have 10 cents, what am I going to do? That's too much. I need change back. I'm going to take away 2. So my final answer is 15. I can show you again on my abacus. I can add the 10 and I take away the 2. And my final answer is 15. I guess what I would do is, what would happen if I had $5, right? How do you get change back? Because we deal with money. It's faster. It is faster. Thank you. I appreciate that. You know, it is faster and it's also a concept, but then it's also versatile. Oh, that's what I was going to do. I forgot. So here, let's go back a step. Let's go back a step. So that was the thing, right? They were like, well, why don't you just count up? I'm like, I don't know. So we have 1, 3, 5, 7, 8, right? And now what are we going to do? We're going to add the 2. Can we add the 2? Yes, we can add the 2. Can we add the 4? Here, can we add the 4? Guess what? We know how to do it. We add the 5, take away the 1. And then we add the 3, we add the 3, we add the 1, we add the 1, and then the 1. Hello, Richie. So my final answer is 37,889. Hi, Cody. Welcome back, Cody. Yes, the abacus. Does that make sense? So what we're doing is it becomes now scalable. You can do it with bigger numbers. We can do it again with even smaller one, like 26. So if we do 26 and we add the 4, yeah, not a problem. Tell me what your question is. Hopefully it's an abacus question, not calculus. So we add the 3. Add the 3 is what? Plus the 10. I'm sorry, plus the 5 minus the 2. And then I'm going to what? Add the 2. Is there enough? Yes, I'm going to add the 2. So my final answer is 58. So we can continue on with the adding of the 10, which is something I'm trying to... Okay, on this one, you can start any one. If you count up method, it's no better than counting on your finger. Thank you, Pay. Thank you, I appreciate that. That was a good one. That's a good one. So the question is, yeah, and that's what it is, right? You don't want to, I don't know why it is what it is. So 26 plus 32. Can you start on either, or do you start on central? You can start any one. It doesn't matter. You just need to track your numbers. So let's do it both ways, right? Let's do it both ways. Let's see how it works. I'm trying to find colors. There we go. So if I have 26, right? 26 on my abacus. You could do it, it doesn't matter, right? If we start with the 2, we add the 2. Can we do it? Yes, we can do it. Add the 2. We add the 3. Can you add the 3? No, you can't add the 3. Guess what? Plus the 5. 3 is equal to plus the 5 minus 2. Plus the 5 minus the 2. Right? Because every number is individual. It doesn't matter which way you go. It's the same thing with the other way. So if I have 26, right? I have 26. I want to add the 3. It's the same thing, right? Plus the 5 minus the 2. And then here, I want to plus the 2. So you just got to keep track. How do I keep track? I use my finger to track it. So that's what I would do. And I would say it out loud. So somebody was asking me, like, how do I know? I would say it out loud. If I have the 2, I'm going to plus the 5 minus the 2. Plus the 5 minus the 2, and then plus the 2. That's what I would do. If that makes sense. Yeah, it doesn't matter which way. Ha! Food. This time I'm going to use a timer. You know, I do. I use utilizing the timer. Timers are fantastic. Does that make sense, Cody? So it actually doesn't matter. Oh, we can continue on. Let's do kind of the same one. Let's do kind of the same one. Okay. Let's do this one. Let's do 26 plus 39, right? We can do it. So in mainstream math, what do? We do 15, right? We know this is 1 and this is 5. Notice that this looks like that, right? In mainstream math, 15, 10, and 5. But in Abacus, what do? We have 20, we have 6. In mainstream math, we're going to add this 10. We're going to add the 9. How do you add the 9? See, I think that's the difference, right? We're going to add the 9. When we add the 9, what do? Plus the 9 is equal to plus the 10 minus 1. Because we're constrained with this, we want to add the 10, but we have to take away the 1 because we cannot count up. Just as Pei mentioned, we don't count up. What we do is we balance the equation. We plus the 10 minus the 1. And then we do this, plus the 3. Plus the 3. When we plus the 3 is equal to plus the 5 minus 2. Plus the 5 minus the 2. So my final answer is 6. I'm sorry, do all my books colorful abacus? Do the books take the colorful abacus, or do we need the brown one too? You know what? It depends on the child, actually. The colorful one is just meant to be nice and colorful, and just it's easier to see when it's gradients. And the brown one is fine if you want to just do the brown one. The brown one's fine. The reason why I do brown for the older kids is because when you do multiplication and division, you have more room on the abacus to track your numbers. You could use. There's a lot of people that use the colorful one, and then they graduate to the single colored one. I would not recommend doing a colorful one, 13 columns, because I feel like that's a lot of color for the amount of how big it is. And I think this size for the color is good, if that makes sense. So you can use just one. You don't need both. That would be the question. Is that the question? Do you need both? You don't need both. You can choose one or the other. But notice if you choose the colorful one, you might need to upgrade to the more digits because size matters. So my 8-year-old is okay. My 15-year-old, I would recommend the brown one for the 15-year-old, because when you start doing multiplication and when you do division, it's a lot. You just have more space to play with. If they're open, here's another thing is if they're open to learning something new, then I would do it. Right? 15, they might be like, this is too easy. And it all depends on their attitude. I started my kids young, so they didn't have a choice. There are some parents that have children that are very open to new things, and it's great. If they're open to new things, it will change the way they're thinking math. But it will be a struggle in the beginning because just like my lives, right? In my lives, people are like, well, this is too easy. Why are we doing this? I'm like, well, we need to do this because we need to understand the fundamentals, if that makes sense, right? We need to know the basics. We need to understand how to move the beads. So that's why we go slow. But then once they get it and when they come understanding, then it'll be great. But it's an attitude that you have to kind of maneuver as well. I'm not saying that this is I'm not saying that this is the end all. I'm just saying that there's going to be some, depending on how the attitude is of people in general. So, but yeah, it becomes interesting because here, if you notice, you already know how to add the 10 and you know how to add the 5. Now this becomes versatile and it doesn't matter. And that's the secret to adding and subtracting. The secret to adding and subtracting is if you know how to add the 5 and how to make it 10, everything under the sun is scalable. This is it. All you need to do is this. But we can take it one step further. There's this thing called two-step equation. Two-step equation means what? We're actually going to take our 5 and we're going to take our 10 and we have to modify it and incorporate the 5. What does that mean? So here's a question. We have 7 plus 7. Here is the concept that I'm trying to explain. So if I have 7, we know what 7 looks like, right? We add 7 on the abacus. And then what's going to happen is we need to add another 7. So to add another 7, we don't have enough. 7 is equal to plus the 10 minus 3. That's the formula that we need to do. So plus the 10, right? 10 is what? 1, 0. Plus the 10, add the 3. Notice there's no more beads to add the 3, or take away the 3. There's only 2 beads to take away. We need to add the 3. This now becomes something that we've seen before. We know how to take away the 5. We can modify it and say minus the 3 is equal to minus the 5 plus the 2. Oh, Punk Bunny, you know what might be easy is, or might be beneficial for you, is this laminated book for your 15-year-old. Because then what I have here is I have the cumulative property. And in the cumulative property, I'm showing you how we add, right? We have plus the 4, plus 3, plus 2, plus 1, and we combine the 2. You can go either plus the 5 minus the 4 or minus the 4 plus the 5. I don't know if this is too much. And then this one also is the tens. So here we make the 10. This is the set that we need to memorize. This is the set we need to understand. But notice we have a 9 and the 9. So you add the 9, you subtract the 9. And it goes all the way to 1. And then here, the way I did it was I broke it up. We start with making the 5. And you'll notice that I have a little label. This is my prototype, but I have a little label at the end, at the top. And what it is you take the number, you isolate it, and you substitute it. And I give you sample questions at the bottom. So here's a sample question. If I want to add the 4, right? Add the 4. I want to add another 4. I'm going to substitute 5 minus 1. 5 minus 1. And my answer is 8. So then, if you know how to add, right, you will know how to subtract, which is behind. So because we add 4, we can subtract the 4 in the 5 concept. And it's the same thing. We have the 3 and then the minus 3. 2 and then the minus 2. Add the 1 minus the 1. And then we do the 10 again. After we do the 10, right, it's the same thing. The concept is the same. Isolate the variable. Isolate the variable. All we need to do is understand our pairs. Now the beauty thing about it is not that you can, after you add the 9, take away the 9, right? The beauty is right here. Here is the process that we go. This is the Abacus workflow. The Abacus workflow is here. If I want to add any number, this is the workflow I need to ask. Here I have the question 7. If I have 7 on my Abacus, can I add the 4? You've heard me say this. Can you do it? No, I can't. So I got to go here. Can I add the 5? Yes. Can I add the 5? No. I'm using it already. So that means I got to do the 10. Because I have to do the 10, I need to minus the 10 plus the 10 minus the 6. So I'm going to plus the 10 minus the 6. And my final answer is 11. It does it again. You can do it again with subtraction. So here I have 17, right? And then I have my question. Can I take away the beads? Yes or no? No. So I go down the line to my workflow. Can I take away the 5? Yes, I can take away this 5. What do? Minus the 5 plus the 1. Minus the 5 plus the 1. So my final answer is 13. I really like this one because it's so concise and it's I think it's very well organized, if I don't mind me saying. But that's what this is. That one is, and it's a laminated. It's a laminated, and all of the Abacus formulas is right here. And then there's a workflow. So no matter what the number is, you can utilize it. Maybe your 15-year-old will benefit this one more than, and then also read the Abacus. You can use a dry erase, and then you can also bring in a little bit of algebra. Like if I have x, this is my x, right? I like my save for some later. Yeah, I like it laminated. Well, I teach from it, so I feel like it's just easier. And if you wanted to do a review, yeah. But yeah, this is all laminated, and I bind it too. But I like the way it's organized. I think it's very concise in the way I have it too. And I think what's really beneficial is the framework. The framework is all in one, and you just go through. So we can show you. I can show you how it works. So this is, we add the 7. So add the 7 is over here. Can I add the 7, yes or no? No. So I have to go here. Add the 7 is what? Plus the 10 minus the 3. So I'm going to plus the 10 minus the 3. Now when I take it, I have 7. I want to add the 10. Can I do it? Yes. Then I'm done. I'm done with this. Now I have to minus the 3. Excuse me. I have to minus the 3. Can I do it? No. I don't have any beats to minus the 3. I'm right here. Do I have enough beats to minus the 3? No. So I can go here. Can I minus the 5? Yes, I can minus the 5. Guess what? Minus the 3 is minus the 5 plus the 2. So that's why I go here. Minus the 5 plus the 2. So it's not just, thank you, yes, thank you, Punk Bunny, yes, right? So there's a framework. You follow the framework, you follow the workflow, you'll be able to answer any question. We can do it again. And then it becomes a program, it becomes a loop. You know, like in programs, there's a loop, now it becomes a loop. So if I did, I don't know, 500 minus 7. I don't know, we'll do that. 500. 500 is this. Take away 7. Can I take away the 7? No, right? I just go down here. Can't take away the 7. I know how to do this. Minus the 7 is minus the 10 plus the 3. So when I write it, I could do plus the 3 minus the 10, right? Minus plus the 3, because I'm going to add the 7 here. I'm going to take away the 7. So I'm going to plus the 3, and then I need to take away the 10. Do I have enough to take away the 10? No, I don't have enough to take away the 10. Can I take away the 5? No, I have no 5 to take away. So that means I have to do this. I'm sorry. Yeah, that means I have to do this. Take away 1. Take away 1 is what? Plus the 9, take away the 10. I'm going to write it this way. Plus the 9, take away the 10. So I'm going to plus the 9. I'm right here. I take away the 10. Can I take away the 10? I need to take away 1 here. Well, guess what? I go back to here. Can I take away? No, I can't. Can I take away the 5? Yes. Take away the 5 is what? Minus the 5 plus the 4. Minus the 5 plus the 4. So my final answer is 493. So this is where we call about, well, this is what I'm saying about critical thinking. We start going through each problem. We start going through each number. Every number needs to be completed before you go to the next number. And then it gives you a process, right? Now there's a process and there's like a little checklist. Because there's a checklist, then you can start going through it. And that's how, just how I feel like Matilda. Ah, that's funny. Right? And it's interesting, when you do arithmetic, when you do adding, subtracting, it's very much process driven. And that's the strange thing about mainstream math, is that they give you all these different ways to add and subtract and number bonds and stuff. And I'm like, that's a lot of strategies. It's a lot of strategies for something so simple. They make it sound so complicated. So here was a number bond. So let's do a number bond. There was this one, here it is. They did number bonds. And I know the difference is on the abacus, we don't need to worry about the different place values. But on paper, because the sky's the limit, we don't know what we're doing, right? So what does that mean? Well, here, what did they do? They have 14 plus 68. They broke it up into 2 circles. And then what happens? One's a 10s and one's a 14. And they broke it up, right? 6 and 8. And then they take the 60 and the 10 and they bring it together. So that's a 10s. And then they did this, which is the 1s. But then guess what? They have to do it again with this 12. I'm like, okay, well, whatever. So on the abacus, we could do it. We do the 1 and the 4, right? 14. and then we add the 10, add the 8. We know how to add the 8. Add the 8 is what? Plus the 10 minus the 2. And then we add the 6. Add the 6. That's all we're doing. We're adding the 6. So my final answer is 82. So, I mean, I can see it. I understand what they're trying to do, but it's still abstract things, and it's still difficult to see. You could do it with these blocks. That's fine. You could do it with the blocks, but guess what? Another thing, if I don't know if they know, but the human eye can't see a bunch of stuff like this. We actually do, if you've noticed, we actually break it up into more manageable chunks. So we break it up and then we break it up again. So then we know, oh, it's 5, 10, whatever, 15, right? To do 14, it's, right? To do 14. What did I just do? I did 5, 10, 14. I did 5 first, 5, 10, 15, and then I took away the 1. So you could do it with the number blocks, but again, the human eye can only see like 5 items at a time. So that's why if you go more than 5, we have to start breaking it up into separate groups. Yeah, remember? Yeah, the abacus is easier to see and remember. Yes, thank you. Thank you. I appreciate that. Oh no, I'm so sad I'm missing math time. Oh, hi, Dina. I have acupuncture. No, not a problem. I'm going to be on later. I'll be on later tonight. I'm always on because I think I'm trying to spread the good word of the abacus. Because
This is the way.
This is the way. This is the way.
midnight math. Yes. Yeah, today's Saturday, so we should be good. Yeah. Yay. I'll see you later, Dina. Enjoy your acupuncture. I love acupuncture. It's really good. Okay. So, anybody have any questions? I mean, we can do multiplication. Multiplication's easy. I'll start small. Here, distributive property. So abacus world, we call it distributive property. Right? Distributive property. Distributive property is what? We're just breaking it up. I think it's an algebraic term, distributive property. The first thing we're going to do is we're going to understand how to put our answers. Where are we going to put our answers? We know it's going to be the hundreds. 1, 2, 3. So we know if we add it all together, it's going to be some sort of... No, don't be scared. This is going to be easy. You'll see. So 1, 2, 3. 1, 2, 3. Because we're here, okay, I'm hoping you know your times table. That's the biggest thing. So we do 8 times 9. What did happen? We do this. 8 times 9. What is 8 times 9? 8 times 9 is 72, right? 72. So guess what? I'm going to add my 7. I add my 2. Now what are we going to do? Now we're going to do 8 times 3. 8 times 3 is what? What's 8 times 3? Excuse me. Okay. What's 8 times 3? Thank you, Pay. 24. So I had my 20 and I had my 4. So my final answer is 744. Now it's different in mainstream math. Mainstream math, again, because they have paper, the sky's the limit. Paper, they have to do 90 times 8. I don't know about you, but we don't memorize 90. Our times table doesn't go up to 90. So Abacus makes it into manageable chunks. That's what I just did. Manageable chunks. We can do another one. What's another one? How are we doing, Punk Bunny? Does that make sense? You all right? Thank you, Pay. How are we doing? Right? Makes sense. Easy. I'm telling you. It's easy. We can do it more. We can do another one. Guess what? I made more mazes, but this time it's multiplication. So here. So when we're doing it, right? And this is another book I'm going to do more mazes, but it's going to be a different thing. Let's do another one. Okay, great. Thank you, Pay. Thank you so much for the encouragement, cuz I'm like, I don't know. Okay, let's do this one. So here's another maze book. I'm going to create this maze book, and I think this is going to be the greatest thing next to sliced bread. And the way I have it, but see, the thing is I got to figure out what I'm going to do in the beginning. So here the first thing is do what? We're going to count. 1, 2, 3. I need to use a pen. Let me use a pen, right? 1, 2, 3. 2 times 4 is what? 2 times 4 is 8. Now, in 8, we have to remember it's a single digit. We got to make it a double digit. How do we make an 8 a double digit? It becomes a 0 and an 8. That's something that you're going to have to memorize. That's something you're going to have to know. Does that make sense? Like time. We do 108 or 1207, right? 07. That's how we make it a 2-digit. So that's why it will be 08. Does that make sense, Punk Bunny? 08. And then we do 2 times 5. 2 times 5 is equal to 10. Add my 1, add my 0. My final answer, thank you, Pay. Thank you, Punk Bunny. My answer is 90. So I find my answer. Here's my answer. And I go up to here. Does that make sense? So now we do it again. 1, 2, 3. 9 times 8 is 72. Add the 7, add the 2. So I have my answer, 720. And then it takes me to here. And I do it again. 5 times 2. 5 times 2 is what? 5 times 2 is equal to 10. 1, 0. And then what? 5 times 7. 5 times 7 is 35. 35. Add the 3, add the 5. Thank you, Punk Bunny. Thank you, Pay. Make sense? So now my answer is what? 135. I find 135. I'm over here. So then I'm over here. I count it again. 3. 1, 2, 3. 7 times 8. 7 times 8 is what? 56. Thank you, Punk Bunny. 7 times 1. Thank you, Pay. 7 times 1. 7 times 1 is 1. I'm sorry, 7 times 1 is 7. Again, what we're going to do is we're going to make it a double digit. It'll be a 0 and a 7. So 0, 7. So my final answer is 500. What's my answer? 567. 567. Takes me to here. Make sense? What are we going to do? 1, 2, 3. And then we practice. 5 times 8. 5 times 8 is what? 40. 4 and a 0. 5 times 2 is 10. 1. So my answer is 410. Easy? See? Are you scared, Punk Bunny? No, right? Don't be scared. Easy. So it takes me to here. And now I'm here. And I do it again. So what we do in Abacus is we call distributive property. We go one number at a time. 8 times 2. 8 times 2 is what? 8 times 2 is 16. Add 1. Thank you, Punk Bunny. Add 6. Right? 16. 16. 2 times 4 is what? is 8. 8 is a single digit. How do you make it a double digit? 8 is a single digit. So we got to do a 0 and an 8. Yes, right? Easy. So what's my final answer? 168. 168. So it takes me to here. The conventional method of funny. The conventional method of is to yes. Yeah, I know, right? So we do it again. 1, 2, 3. 2 times 3 is what? First. 1's first. We can do it the other way. We can do it the other way. But you'd have to track it. I don't do it the other way. But I do. Yeah, you could do it the other way. So we do. No, you know what? You know what? In new math, they're starting to go from left outside in. New math, they're doing this way. They're doing Abacus way, which is interesting. Old way, we start with the 1's first. So the 1's would be 4, and then we go here. And then we do 6. 2 times 3 is 6. So it'd be 6. Yeah. Yeah. It's interesting. Hello, Otis. Right. I guess I'm too old for new math. Hey, Cookie, good morning. Yeah, it's funny. I was doing research. I was actually doing research on new math and old math. And then I realized that new math is starting to do it the outside. I don't know how they do it for double digits, but for Abacus, it's the same way. What we're doing is we're doing multiplication, Cookie. This is my new, this is going to be my new book, Multiplication Maze. Okay, so we're here now, right? 64. Or we go here. 3. We could do it the other way. We could do 3 times 2 is 6. We add the 6. So I guess if we do it this way, we don't need to track if it's single digit or double digit. And then, what? Because we do 3 times 2 is equal to 6. And then 3 times 4, we have to know to go here, is 12. 3 times 4 is 12. 1 and 2. You could, I don't know. 126. 126 takes me to here. We know this, right? 28 takes me to here, and then here. So we count. 3 times 1 is equal to 3. 0, 3. So we add the 3. And then 6 times 3 is 18. Add the 1, add the 8. So my answer is 48. It takes me to here. Now, the reason why I have the 1 times is just so we can practice, right? 1, 2, 3. 1 times 1 is 5. 5 is 0, 5. Add the 5. 1 times 8 is 8. 8 is 0, 8. So add the 8. So my final answer is 58. And then 4 times 4 is 44. Oh. Okay. Sorry. Excuse me. Okay. Yeah. So, how are we doing? Punk Bunny, you alright? Wow. Wow, we have 20 people here. Wow, I'm at 16,000 likes. Thank you, guys. Does that make sense? I told you. Don't be scared. It's easy. Abacus makes everything just more manageable chunks. Abacus makes adding, subtracting, multiplication, division into manageable chunks. Hello, everybody. Welcome. My name is Lynette. I am an Abacus teacher. I'm here to teach math with an abacus. And I think Abacus is the greatest thing next to sliced bread. Easy, right? Yeah. I think the biggest thing for me is to curate all the questions. So I have it where I have like only 2 times table, and then I have it where this is just like, yeah. It's a lot about curating the questions. And I think that's the problem with mainstream math, is that they don't curate the questions, so they just give you a bunch of numbers. But there's actually a pattern to everything. And I am figuring that out. Yeah. So I made a whole, like, more than, 56 mazes. But we can go on. Okay, how are we doing? How are we doing? What's going on? Thank you, everybody, for joining. I didn't... What am I doing? I had a maze. Oh. Excuse me. I have, like, all this paper. I gotta organize myself better. Okay. What's going on? Anybody have any questions about the abacus? Whoa. Sorry. So, let's see. Wow. Cool. No, that's not what I want. Reviewing the friends? No, that's not what I want. Yep, I have activities. I printed it out, and I just gotta find it. Here? No. I can't find it. What I'm trying to do, I'm trying to find this, my questions. I have a bunch of questions that I was going to do. Yeah. So, let me see. How is it going? Are you a teacher? I am an abacus teacher. Oh, here it is. I'm an abacus teacher. Am I a school teacher? No, I'm not a mainstream school teacher. I teach abacus, and I've been teaching abacus for about 20 years. And what it was is we opened up a school. We opened up a learning center out in Monterey Park. I'm located in Monterey Park, and my dad was the one that said, "You're gonna learn abacus," and I'm like, "I don't know what it is," and he forced my brother and I to learn how to use the abacus. So we're teachers. We've been teaching abacus for about 20 years, and I started to realize how this is the greatest thing next to sliced bread. And the interesting thing is, what I'm trying to do now is how to relate abacus to mainstream math, which is very interesting. It's a very interesting path because abacus world doesn't do that, and nobody in mainstream knows what an abacus is. So I'm trying to bridge it and understand how to make it more relatable. And that's why I have my terminologies that I use, because in abacus world we don't use the words like substitution, and we don't use the words like isolate the variable, but because I'm teaching you guys, right, I wanted to make it more understandable for you. Yeah. So I don't know. Excuse me. So let's see. I'm just looking at trying to see. How are we doing? Anybody else have any questions? So for those of you that just joined, hello, my name is Lynette, and I am an abacus teacher. This is an abacus. Here is my abacus, and what we're going to do is we're going to understand and do a little review. Let's do a review on how to read the abacus. So we have 1, that's 1. So we have 0, and then we have 1. This is 2, 3, 4. And then we have 5, 6, 7, 8, 9, and then we have 10. This is available here. After 10, we have 11, 12, 13, 14, and then we have 15. After 15, we have 16, 17, 18, and 19, and 20. So, anybody have any questions, let me know. What we're doing is we're learning how to use the abacus, and after you learn how to use the abacus, then you can go into adding and subtracting. This is what we just did. We did adding, subtracting, and multiplication. You can do division, but I think that's a little bit more advanced, and so I would rather just keep it at multiplication, like this multiplication that we did. So usually what I do is just go through adding, subtracting, and multiplication in the beginning parts of my, So here's another one we could do if we want to solidify our understanding. Here is 400. 400, right? Take away 146. So what are we going to do? We're going to take away 100 and then take away 4. Take away 4 is what? Minus the 4, we know we cannot take away the 5. So we do minus the 4 is equal to minus the 10 plus the 6. So it's minus the 10 plus the 6. And then we're going to take away 6 here. Minus the 6 is equal to what? Minus the 10 plus the 4. Can't see it? There we go. So we minus the 10 plus the 4. So my final answer is 254. All right, how are we doing? Anybody have any questions? Can you do that again? Yes, let's do it again. Let me get you better paper. Um, 400 minus 146. Okay. So we have 400 on my abacus. 1, 2, 3, 4. I would go this way from left to right, right? So, can we take away the 100? We're here, right? We're here. Can you take away 100? Yes. Take away the 100. Now we're here, right? Can we take away the 4 from the 0? No. What can we do? Can we take away the 5? I'm sorry, can we take away the 5? No, there's no 5 to take away. So what do? I have to take away the 10 plus the 6. Thank you, pay. Yes, thank you. Take away the 10 plus the 6. I'm done with that one. Right? Now I'm here. Can I take away the 6? No, I have no beads to take away the 6. I know what? I know minus the 10 is what? Minus the 10 plus the 4. Minus the 10 plus the 4. Thank you, pay. So my final answer is 254. So how do we do it in mainstream math? Well, mainstream math, right? We do borrowing. And there's a whole bunch of strategy with it too. It's crazy. You know why? Because we need to know, it takes practice because you need to know how to minus the 4. Minus the 4 is equal to minus the 5, minus the 10, plus the 6. The 6 is minus the 6 is equal to minus the 10 plus the 4. There's many different strategies that they're doing, and I'm looking at it, where, in mainstream math, what do? Mainstream math, old way, we cross it out. We have the 10, 400. We add the 10, we cross this out to 9, and then we cross this out to 3. That's what we do. And then we do whatever. We do 4, 5, and then 2. But in Abacus, we know how to use our formulas. Right? There was another way they started doing it. There was another way. There was another way where it was 100 minus 4, 6. And then it was like, if this is 3, this is minus 6, and then this is minus 4. I was like, oh my God, it's another strategy to take away. So what happens is, this is 30 minus 6. That's what this is. So then it's like 24. And then, because it's a 4, it's 40 minus 4. So then this is 36. I don't even know what I did. Oh my God, I can't do that. I don't even know what I did. Anyways, that's another way of new math. Oh my gosh. Yeah, that gets confusing. Abacus mechanical math. Yeah, right? I mean, it's very process driven. So there's another way they did it here. I don't remember. I don't remember how they did it. There's so many different ways to do, there's so many ways to do new math. And I'm like, if you just understand this basics fundamental, all you need to know is, remember, minus the 4 is equal to minus the 10 plus the 6. Minus the 6 is equal to minus the 10 plus the 4. Then you have everything under the sun. There's a lot of strategies. There's so many strategies for new math. And they're like, this is a better way. And I'm like, oh, okay. They don't do all these strategies in other places in the world. They only do it in America and maybe Canada. Because they're trying to reinvent the wheel. They're trying to keep reinventing the wheel. But they just don't go to the abacus. They always have like these counting bears, or they have these like little flippy coins or whatever. But just go back to the abacus and it's just much easier. Yeah, new math is no joke. I'm telling you. Like, there was this one person. They were like, it took me a while to do the lattice. I forget, it was addition or subtraction. I don't know, whatever. The lattice. And it wasn't about like counting the lines. It was really weird. Anyways. Yeah, you're welcome. Yeah, you're welcome. Let me know if you have any questions. But I can do another one. We can do another one. You know what? Let's do one more and then I'll sign off. Let's do one more and we'll sign off. Yeah? So we can do another one. Whoa. You want to do 700? We'll stay with the one step, right? 700. Two more? Yeah, okay. We'll do two more. So let's do that. Yeah. Yeah, not a problem. Not a problem. It's because I have the questions. If I had to think the questions, I'd be like, because sometimes the questions can be a little difficult. Because that's why like we have to curate. That's why I have to curate the questions. So I did these ones ahead of time, so that's why I know these questions. So we have minus the 5. So we take away the 5, can we do it? Yes, we can take away the 5, right? Oh, we're right here. Can we take away the 5? Yes, take away the 5. Now we're here. Now we're over here. Right? Now we're here. Because we're here, can we take away the 2? No, we can't take away the 2. Well, what can we do? We can't use the 5, right? Now we're going through this concept. We can't take away the 5. So what do? We have to take away the 2. How do we do it? Can you write it in the chat? What is my formula to take away the 2? Take away the 2 is what? Thank you, Cookie. Minus the 10. Why? Minus the 10 plus the 2. Because it's minus the 2. I'm sorry, minus the 8. Minus the 10 plus the 8. That's what we're doing. Minus the 10 plus the 8. Yep. It just takes time to understand what we're doing. That's all. It just takes time to understand that these are very versatile, right? So then our next one is this. 6. Can we take away the 6? How do we take away the 6? We want to take away 6 right here. How do we take away the 6? So go back to here. Can we minus the 6? How do we do it? Thank you, Cookie. Yes. Minus the 6. Minus the 6 is equal to minus the 10 plus the 4. Can I do it? Yeah. Take away the 10. 1, 0, right? 1, 0. And then plus the 4. Add the 4. So what's my final answer? My final answer is, please put it in the chat what my final answer is. $174. Thank you, Pharaoh. Yes, 174. Cookie. It's different. Why? Because you're seeing it in the video. Obviously, if you had it in front of you, you could see that there's a 5. I understand. So let's do one more. We do 500 minus 364. Hey, hacker. 284. I don't know what you're talking about. Okay, so now we're here. Oh, there you go. All right, 500. Did we do this one already? 500. I have no more room. I gotta, there we go. 500. There we go, much better. Okay. Did we do that? Okay, let's do another one. Punk. Pays tracking. Okay, that's fine. We can do this one. We can do a bigger one. Oh, I said 174? Oh, oops. I'm getting tired. This is my last question. I'm going to sign off. Yeah, when I start making mistakes, then I'm like, okay, I'm done. All right. Yeah. No, thank you, hacker. I appreciate that. All right. So here we're doing. I gotta. Is that better? Because I have so many peripherals. You know what? I'm going to do this. We'll do that. All right. So, we do 100, take away 38. Right? 138. So we're going to do here. Can I take away the 3? Can I take away the 3? No. How do I take away the 3? Minus the 3 is what? Minus the 10 plus the 7. Thank you, Pei. So minus the 10 plus the 7. We're done with this one. And we go to here. How do I minus the 8? How do I take away the 8? Minus the 8 is what? minus the 10. No. The partner of 8 is not 8. The partner of 8 to make a 10 is 2. So it's minus the 10 plus the 2. So it's minus the 10 plus the 2. Thank you, Cookie. Thank you, Pay. Did that make sense, Whitney? Why? Because what we're trying to do is we're trying to utilize our... I'm sorry, I'm sleepy too. Oh, yeah, okay. Okay, so you know. Yeah. Yeah, it's getting tough. So what's my final answer? My final answer is 62. Yeah, it makes sense. Okay, yeah. Okay, good. Just want to make sure. But yeah, the partners, that's one thing. And then, yeah, that's all. That's what. Thank you for working overtime, Lynette. Ha! You're welcome, Pay. Thank you. Not a problem. I appreciate everybody joining and commenting. Now I don't feel alone in the room. You know what I mean? So I do appreciate when you help me with the formulas. Thank you so much, Whitney, for the follow. So thank you, Cookie. Yeah, not a problem, Cookies. Thank you so much for joining again. I appreciate you. But yeah, that's the thing. I'm actually quite excited about my multiplication maze. I think the multiplication maze is going to be pretty good. Yeah? What do you guys think? Multiplication maze? It would be good for the kids that are learning multiplication. Yeah? I'll be back. Oh, good. I hope you'll be back. I'm so happy when you guys join. I like it when my regulars come back. It's great. Really? Okay. Thank you for the encouragement. I will see what I can do to publish it out, and then we will. I want to do the other way. I don't know if I'm going to do division on the maze. I'd have to figure that one out. Because I want to bring it together. Yeah, the maze looks interesting. Hey, Farrell. Yeah, right. And then you practice. Hello, AI TikTok God. But I'm actually leaving. I'm done. So you don't need to share. Thank you so much, though. I appreciate it. But I'm gonna sign off. I've been on for a few hours. So thank you again. I appreciate it. Hello, AI TikTok God. Yeah, no need. Not right now. Right now I'm gonna go. Okay. Thank you so much. I appreciate that. Thank you, Pay. Yeah, I think okay. So then that's what I'm gonna do. I'm gonna make another book. It will be multiplication, and then I'm gonna section it off. It'll be interesting. It'll be only two digits times one digit. That's the whole book. 2 digits times 1 digit. But there's gonna be more to it. Yeah, I think so. Thank you guys so much for the encouragement. I appreciate it. Have a good day, everybody. Have a good day, and I'll see you guys all later today. I don't know. Have a good night. And I'll see you guys all in my next live. Bye, everybody. Thank you. Bye, Punk Bunny. Right, Punk Bunny? Multiplication's not scary. You did it. See, you can do it. Multiplication's not scary. It just needs to be structured. Once it gets structured, then everything's easy. All right. See you later.